Hello and welcome you all for today's session. Today's session is about matter in our surroundings, a first chapter in the science textbook of class 9th. We bow Almighty for the creation of wonderful and beautiful world. When we look at the surroundings, we see the different kinds of things which differ in size, shape and color. There are a lot of things in the creation which differ themselves in properties. For everybody, the question strikes, that is, from what these all things are made up of, or what are the constituents of these wonderful things. And all these constituents are being described by the scientist, and these substances are called matter. What is matter? The matter is nothing but the water we drink, the food we eat, the air we breathe, the cloth we wear. All these are matter. In the previous year, you have learned about synthetic material, acids and bases, metals and non-metals. Of course, all these are matter. Today, we discuss more about the matter and the properties, and to know about the composition by which they are made up of. So what is matter? Matter is nothing but anything that occupies space and has mass. Even though the air that we cannot able to see, it is matter because it has mass and it occupies space. So we can give the example for the matter is food, clothes and water, etc. Then question arises, what is not a matter? If everything around us is a matter, what is not matter? The feelings have no mass or they won't occupy space. Therefore, the feelings like smell, love, hatredness, all these are not matter, or they are non-examples of matter. Remember that the perfume is a matter, but the smell of a perfume is not a matter. Smell of a perfume is not a matter. Then let us see, is there any common property among all that things that we find that constitutes properties of matter? Suppose if we take a sugar in a beaker and try to dissolve it, try to stir and dissolve it. As we see here, is there any change in the water level after addition of the sugar? No. And what we find is sugar after some time is disappearing. Probably it is getting mixed with the water. And why we cannot able to see the sugar molecules? It is because the particles of sugar are segregated. That means particles of matter are very tiny. They are very small. They are of the order 10 to the power minus 9 meter. And this is called nanometer. So they are of nanometer size. They are of nanometer size. Therefore, when the particles get segregated, we cannot able to see them at all. So when sugar dissolved in water, we cannot able to see the sugar particles. But how do we find out that sugar is present? By the taste we can able to say that the sugar is still present there. And remember that sugar is segregated into each particle. So every matter may be like this also. So if you take a glass sheet, it looks as if it is made up of one complete thing. but when it breaks, you will get the small particles of it. So every such particle is also consisting of the smallest particle within. So every matter is consisting of small particles, and it is not the one whole thing, but it is made up of smaller and smaller particles. One more point that we have seen, the matter is consisting of tiny particles. Okay, one of the observations that we made. Another observation that we have made in dissolution of sugar is, sugar after addition, the water level has not significantly changed, or water level didn't change at all. Where the sugar particles are occupying the spaces between the water. That means matter consisting of particle, and the particles have space between them. So particles of the matter have space between them. Whether it may be solid, liquid or a gas, there is a space between the particles of matter. See, we can move our hand freely in air as if we do not feel that there are particles. As there is much space between the particles of air, we can able to do so. But the same thing that we can do, move our hand in the solid also, in the liquid also, but with difficulty. But in solid, we cannot move our hand, because it also talks about the kind of attraction between the particles. If the particles are attracted each other, then for moving our hand, we have to break the attraction between them. So in solids, there is no much space between them, and also we cannot break the force of attraction between the particles so easily. Therefore, the particles' attraction force is higher in solids. So we can conclude that all matter, the particles of matter, have attraction between them. The kind of attraction or the strength of attraction may differ from solid to gas or any other kind of material. And let us try to know about the different physical states of matter. There are three different states of matter: solid, liquid and gas. As I already told about, solid, liquid, gases are present as a matter. They are called physical states of matter. You have seen ice, water, and felt about the presence of moisture. The same water can exist in solid, liquid and gaseous form. So water can exist in three states. So they are called physical states. So they differ in physical properties because they are having same composition. Water is having same composition, but they differ in the physical properties at different temperature. Now let us try to see about what are the properties of solids. Solids have definite shape and volume, fixed volume. Solids have definite shape. Solids have definite shape because the particles are held strongly to each other. When the particles are held strongly, they become rigid. They do not have the flexibility or the movement. When the particles are held together strongly, their attraction force is more, then they get definite shape. So the rigidity of solid can be explained or can be understood by knowing the attraction between the particles. Let us look at the way the particles are arranged. Particles are arranged in the solid. So in the solid, the particles are well organized. They may be moving, but they are moving only to and fro. They have only to and fro motion. And they are not moving from one place to the other place. This is called translatory motion. This is called vibratory motion. Solids have vibratory motion. they move from the mean positions. The space between the particles is minimum. There is space between the particle, but particle space is minimum. Therefore, they are least compressible. Whenever the compressibility comes, we will think of a syringe. So let us take a syringe and plug with a rubber cork or a cotton, and we take solid, liquid and gas and try to compress, and we see that solids are not compressed more because of the arrangement of particles. But in case of liquids, there was space and can be compressed. But in case of gases, there is much space and can be compressed more. So, solid, liquid, gases, if you compare, solids are having more compressibility than liquids. Solids have less compressibility than liquids, and liquids are less compressible than gas. Gases are highly compressible. So, the compressed gas are being transported, right? So, gases are, when they are put in cylinders, and in they put in cylinders, gas cylinder that we use for the domestic purpose, it is highly compressed gas. So, CNG, LPG, all these are available after compression into cylinders, right? So, compressibility speaks about the spaces between the particles. When there is possibility of compressing, that means there is much space between the particles, right? Now, solids, are they, can they able to show the movement? So, the particles do not move. Their movement is minimum. As I told you, they have only vibratory motion. If at all they have got a translatory motion, that is motion from one place to another place, they would have undergone diffusion. What is a diffusion? Diffusion is intermixing of two or more substances on their own. Diffusion in case of solids is less. Rate of diffusion is least in solids. Suppose if there is a liquid and you put ink on that, it undergo diffusion. On a solid, if you put ink, this will settle there only at the top of it, or it won't be get absorbed at all, or the least diffusion takes place in case of solids. Now let us conclude, let us try to recall all the properties of solid. Solids have definite shape and fixed volume. It is because they have got strong attractive forces between the particles. Solids, particles space is minimum, therefore they are least compressible. And lastly, the moment of particles are minimum. Moment of particles are minimum, therefore diffusion is also least. So these are the properties of solids. Now coming to the liquids. Do they have definite shape? Liquids do not have definite shape. They occupy the shape of the container. And when we see the particles of that liquid, there is much space between them. There is much space between the particles of liquid. So liquids show the translatory motion, that means motion from one place to another place. So we can say liquids, the forces of attraction between the particles of liquid is less or intermediate between solid and gas, and therefore the moment of the particles is intermediate and they are less compressible compared to gases, and compared to solid they may be more compressible. And when they are compressible, less compressible, the rate of diffusion is also intermediate. The rate of diffusion also is intermediate. Right? So, let us take the properties of gases. Properties of the gases. Let us say, what about the shape and volume of this? Gases have no definite shape, nor these have definite volume. They occupy the space of the container. For example, suppose if you have a liquid, let me tell you with taking an example. Suppose you have a liquid. If a liquid, you have 1 liter of liquid, 1 liter of liquid, and suppose you are transferring 1 liter of liquid into a 2 liter vessel. Say you have got a 2 liter vessel. This is 2 liter. 1 liter liquid you are putting into 2 liter vessel, it will exactly occupy half of it. It won't change. So, how 1 liter will remain as 1 liter here. It has got a fixed volume. Suppose if you have 1 liter of gas, 1 liter of gas, and you are pouring it to the 2 liter vessel, you are pouring it into the 2 liter evacuated vessel, then this 1 liter gas will occupy whole of this 2 liter vessel, telling you that now the volume of the gas is 2 liter. So this is for this reason we call that gas has no fixed volume. So it depends upon the pressure, right? So what is meant by pressure? Let us look into that in the other part of this lesson. So gas have no fixed shape or no fixed volume. The space between the particles is maximum. And as we see, what about the compressibility? So it is, compressibility is high. And the attraction force between them is least. So because of that, movement of the particle is high. When the attraction is less, the particles can move faster, and when the particles can move faster, they are having more rate of diffusion. They have more rate of diffusion. Suppose there is a leakage of a gas, so the domestic gas. So domestic gas, when it is undergoing leakage, you will feel it sitting in the corner of the room. Also, you will get the smell because gases diffuse fast, and therefore you will get the smell of it. For indicating the smell of the liquefied petroleum gas, some smelling agents are being added. So they are gaseous form. Therefore, when the gas diffuse, you will smell and get alerted for the leakage of LPG. Therefore, you can prevent the damage caused by the burning of this LPG. So, gases diffuse faster, and diffusion is faster when the temperature is more. Say you have, if you are sitting in the drawing room, you will get of the smell of the food prepared in the kitchen because it is hot. The particles or the vapors get into your nose because of the movement of these particles, and when the temperature is more, this is faster. But if the food is cold, you have to go near to that and smell it. So diffusion is faster when the particles are at higher temperature, when the substances are at higher temperature, and the diffusion is faster when density is less. Therefore, gases diffuse faster. The gases in the atmosphere are in the diffusion state. They are mixed together. Therefore, rate of diffusion depends upon the density of the matter and also the kind of attraction that they exist, nature of the matter, and also the temperature. Now, can we able to let us look at the model of particle model of solid, liquid, and gas. If particles are present in solid, they are well arranged like this. Probably the way that you sit in the classroom, right? So this is just the liquid which are little away from each other, maybe outside the classroom, the way that you present. And this is the way the gas particles are. Probably this is the way you are there in the playground. So particles of solid, liquid and gas, they are arranged in a different way, giving rise to different properties. Is it possible to change from one state to the other? Change of state is possible. Change of state is possible by the effect of temperature, that is heat energy. Heat changes the state. When the solid is heated, it melts and converts into liquid. And liquid state heated, it will be converted into gaseous state. So this is by the application of heat. And we can convert gaseous state into liquid state by cooling. And liquid state to the solid state also by cooling. This process are all being named. So what is the effect of temperature on solid? If the solid particles are like this, if suppose you heat, so they will be converted into liquid. So liquid is because the distance between the particles is more. And they have no fixed shape. So the shape is being changed. Suppose if the liquid is being heated, what is going to happen? So their particles will escape from the liquid state into gaseous state. So the particles, when they are given heat energy, their force of attraction becomes least and they get more of kinetic energy. Because of that, they change the state. So this is how it looks like the solids. The solids on melting, liquid. So particles of liquid are a little bit far away and they have got more kinetic energy than the particles of the solid. And here the gases are there on heating. The liquid, we get vapors and vapors have such model. And this is how conversion of state is possible. So temperature have different scales. Temperature is the degree of hotness. Heat is a form of energy. And two popular scales of that is Kelvin scale and degree Celsius scale. Degree Celsius scale is a normally available thermometers will be having this 0 degree to 100 degrees Celsius. 0 degree is the freezing point of water and 100 degrees Celsius is the boiling point of water. This is how a thermometer is constructed. The lower than 0 degrees Celsius is taken as -10, -20, -30 and so on. So now the question is, what could be the lowest temperature? Theoretically, when it is being determined, -273 is the lowest temperature possible, or at -273 degrees Celsius, no gas will be available in this world. No gas will be there available in the gaseous state. All will be in the thermodynamic, or all will be available in the standard state, standard solid state. Because of this reason, -273 is taken as 0 Kelvin. So this is the lowest temperature, and therefore Kelvin scale has no negative number at all. So Kelvin scale 0. So lowest -273 is Kelvin. Therefore 0 degrees Celsius is 273 Kelvin. 100 degrees Celsius is 373 Kelvin or 373.15. All the scales 0.15 is being added. So this is how the difference between these scales is same, but the number which indicating are different. So 2, if 50 degrees Celsius is being given, if you want to convert it into Kelvin scale, what you have to do? Add 273 to this. 273, 50 degrees Celsius is therefore 323 Kelvin. 323 Kelvin. Or if you want the Kelvin scale, degree Celsius is to be added by 273. To get Kelvin scale, degree Celsius is to be added by 273. You will get in the Kelvin scale. So So this is system of international unit. Temperature is measured in Kelvin scale. There is one more term, pressure. The effect of pressure on gases causes the conversion of state. What is pressure? Pressure is the force applied per unit area. When the force is applied on the gas is converted into liquid. In the gas cylinders, the gases are converted into liquid state. Probably you can tilt and see the sound of liquid inside the gas cylinder. Right? The pressure is applied to the particles move closer, and when the particles are closer, it is the resemblance of the structure of liquid. Therefore this is the condition for conversion of gas into liquid. The more the temperature, more the pressure, so it is easy to convert a gas into liquid. So we can liquefy gas by applying pressure and reducing temperature. So reducing temperature makes the particles to lose kinetic energy. The kinetic energy lost, the interparticle force of attraction increases. Therefore, the gases are converted into liquids and liquids are converted into solids. So the pressure in the scientific book, pressure is the force per unit volume. Okay, force per unit area. It's force per unit area. It should be force per unit area. Pressure is force per unit area. Therefore, what are the units of this pressure are Pascal, atmosphere, bar, and millimeter of mercury are the different units of measuring pressure. Pascal is the SI unit. Newtons per meter square is the way of measuring the units of measuring pressure. Now, is it possible to convert the three states? Yes, by the application of heat and by cooling. The solid can be converted into liquid, liquid can be converted into gas. And also, solid can be directly converted into gas and gas can be directly converted into solid without undergoing the liquid state. And this is called sublimation. The conversion of solid into liquid is fusion and liquid into solid is solidification. Conversion of liquid into gas is vaporization and gas to liquid is condensation. So, the conversion of solid into gas and gas into solid both are sublimation. These are called sublimation. Right? Some substances undergo this change, solid to gas and gas to solid directly without undergoing the change into a liquid state. Such compounds, sublimable substances are naphthalene, iodine, all these undergo the direct change from solid to gas. So this is how the arrangement to show the sublimation. So in this arrangement, take a sublimable substance. Ammonium chloride is a sublimable substance which can be taken here. Tripod stand, Bunsen burner to heat them, converting the solid into gas directly. When they are converted into gas, that should be condensed. Therefore, for which there is a funnel which is inverted and cotton is plugged here. And in the cool walls of this, there will be deposit of this ammonium chloride. So we find that the solid is converted into gas and gas is converted into solid. Two steps of sublimation, two steps that we are going to see in this. So this process is called sublimation. So now what is the way to convert solid into liquid? So when we convert solid into liquid, we need to increase the temperature. So at a particular temperature, the solid melts and changes into liquid, and this particular process is called melting, and at a particular temperature, exactly at a particular temperature where it occurs, that is called melting point of a solid. Every solid is characterized by melting point. All crystalline solids have sharp melting point. Water has the melting point, the ice has melting point 0 degrees Celsius or 273 Kelvin. If you take 1 kg of water, if you take 1 kg of ice, if you take 1 kg of ice, the heat energy required for this to convert this into a liquid, its liquid form, is called latent heat. Suppose if ice is taken in a beaker and keep a thermometer, by keeping a thermometer and start heating, even though you start heating, the temperature of the ice doesn't change until whole of the ice is get melted. So where that heat energy supplied is going? The heat energy supplied to the ice is used for breaking the interparticle forces of attraction, and therefore this heat energy is not used up for increasing the temperature. So the hidden heat is called latent heat. So if you take 1 kg of a solid, any solid, 1 kg of a solid, the amount of heat energy required to convert that particular solid into liquid at its melting point is called latent heat of fusion. Latent heat and the boiling point both measure the kind of attraction between the particles of the matter. Suppose there are two solids A and B. A has the melting point say 100 degrees Celsius and B has the melting point 150 degrees Celsius. It shows that B particles are held strongly. Between the two particles of B, there is more stronger attraction than between two particles of A. Therefore, this latent heat and boiling point both speaks about the kind of attraction between the particles of these matter. Right? Now, conversion of liquid into its vapor, need a heat energy. When the liquid is heated, the particles begins to move and move even faster. Then at a particular temperature, liquid begins to boil. Liquid starts boiling, bubbles are coming out from the bulk of it. So this is called boiling point of water. Okay, that is called boiling point of water. And it changes into gas, liquid changes into gas, and the gas is called vapor. Right? Now, to find out the boiling point of any liquid, this is the arrangement. We have to take a thermometer and the liquid which is heated over a tripod stand with a wire gauge. Then, at a particular temperature, when you go on heating, at a particular temperature, there will be no further rise in temperature at all. So, that particular temperature is called boiling point. What happens? Still we are heating, but still why it is not increasing, temperature is increasing? It is because the heat energy that you are supplying here is used for conversion of liquid state into gaseous state. Therefore, boiling is a bulk phenomena in which a molecule at the bulk also will absorb heat energy to get converted into gaseous form. So, temperature at which a liquid starts boiling is called boiling point. And the boiling point of water, standard boiling point of water is 100 degrees Celsius at 1 atmospheric pressure. Or at sea level, its boiling point is 100 degrees Celsius. Right? So again, we can call the latent heat of vaporization when the change of state is from liquid to gas. So it is the amount of heat energy required to convert 1 kg of liquid into its gas at its boiling point. That is called latent heat of vaporization. Latent heat of vaporization. Right? Again, heat of vaporization, latent heat of vaporization is a measure of the degree of attraction between the particles of liquids. So more the latent heat of vaporization, more stronger the force of attraction between the particles of liquid. Now, there is one more phenomenon called evaporation. Evaporation occurs to the liquids. It is escaping tendency of liquid particles into gaseous form. It occurs on its own. It occurs even at the temperature less than the boiling point of a liquid. And this escaping tendency is called evaporation. For change of the liquid into its vapor at any temperature below its boiling point is called as evaporation. Right? Thank God water is getting evaporated, and after evaporation they get condensed to form clouds, and again clouds shower and we get rain, and because of this movement we are getting the rain, and the water move from place to place, and because of all this reason agriculture and all that are being possible, or we get more facilitated by this arrangement of nature. Now, these particles of the liquid, which are these particles at the bulk, are attracted equally by all other particles around it. But particles at the surface have got less attraction. Therefore, they absorb a certain amount of energy from the surroundings and they break the bond and escape into gaseous form. And always evaporation leads to cooling, because these particles when they break and go up, when they break the force of attraction by absorbing energy from the surroundings, so the effect is surrounding will be cooled. So we go to the water bodies, near the water bodies during summer. It is for this reason, near the water bodies the temperature will be less, right? Evaporation leads to cooling. If you take a petrol in your palm, you feel cool. The palm gets cool because rate of evaporation of petrol is more, and heat from the surrounding, that is from your palm, it gets it from the palm. Therefore, the palm gets cool. You get the cooling effect. After games, you wash your face in the cold water and you feel happy because the rising temperature of the body gets cooled because of the sweat, and the sweat will be again get evaporated and you will get cooling effect. And the water, when you wash the face from the water also, the water gets evaporated, and whenever evaporation is there, the cooling effect will be proceeding, it will be there. So when in the summer season we spray water to the roof, and because it reduces the temperature, and it is because of evaporation again. These are all the things that we do in day-to-day life. And during summer again we wear cotton cloths. Sweat is being absorbed by the cotton, and because of which the cooling effect is more enhanced. Evaporation leads to cooling, and because of that we wear cotton cloths during summer. Right? What are the factors that affect evaporation? So evaporation, the first and the foremost one is temperature. More the temperature, more will be the evaporation, more will be the escaping tendency. Second, the surface area. Even humidity and wind speed also play its role in the rate of evaporation. So when surface area is increased, the rate of evaporation also increases. Suppose you have a hot tea in a cup. So you have a cup and you have a hot tea here. So you will pour it into a saucer, and you feel easy to take the hot coffee from the saucer? It is because the rate of evaporation is enhanced because of the increased surface area. More the surface area, more will the evaporation, and thereby the temperature get reduced. Temperature of the tea get reduced, and you feel easier to sip the tea from the saucer. So, increased surface area increases the rate of evaporation. So, secondly, temperature. Temperature is increased. The surface molecules will show more tendency to get escape. Therefore, the rate of evaporation decreases. Then, what about the humidity? Humidity is the amount of moisture content or water content present in the atmospheric air. If humidity is more, less will be the evaporation. And there is wind speed. If the wind speed is more, then rate of evaporation will become more. That's why the cloths in the windy days will dry faster. The evaporation of the water in the cloths get dried up in windy days, and also during the days where humidity is less. During humidity is less, then cloths are get dried soon. Right? So let us see some of the questions. Check our understanding. Which of the following sets of phenomena would show an increase in temperature? Increase in temperature, diffusion, evaporation and compression of gas, evaporation, compression of a gas and solubility, evaporation, diffusion and expansion of gases, evaporation, solubility, diffusion and compression of gas. So evaporation, does it increase with increase in temperature? Yes, evaporation is a phenomenon which increases with increase in temperature. Diffusion, does it increase? Yes, diffusion increases. Therefore, the smell of the hot food reaches your nose. Therefore, diffusion increases with increase in heat. Expansion of gases. The expansion of gases occur when the temperature is more. Therefore, the answer is C. Evaporation, diffusion and expansion of gas. All the three increases with increase in temperature. Second question. Which of the following represent correct arrangement of substances arranged in increasing order of forces of attraction between their particles? Water, air, wind, air, sugar, oil, oxygen, water, sugar, salt, juice, air. So here look at this. You have to arrange the substances or arrangement of substances in increasing order of force of attraction. So solids, liquids and gases, and the things are solids, liquids and gases, you can distinguish between these. Then the force of attraction is more in solids. So in this case, water, air and wind. Water is liquid, air is gas, mixture of gases. Wind is also a form of a gas only. Now we cannot distinguish. Here, air, sugar, oil. One is gas, sugar is solid and oil is liquid. Again, solid has come in between. But in case oxygen, gas, liquid, solid. So, solid, gas to solid, force of attraction increases. Right? Therefore, oxygen, water, sugar. This is the answer. That is, C is the answer. Right? Now, there are a few questions. Fill in the blanks. Evaporation of a liquid at room temperature leads to a dash effect. So it is cooling effect. At room temperature, the forces of attraction between the particles of solid substances are dash than those which exist in the gaseous state. So at room temperature, force of attraction between the particles of solid substances are stronger than those which exist in the gaseous state. The arrangement of particles is less ordered in dash state. However, there is no order in dash state. So the arrangement of particles is less ordered in liquid state and there is no order at all in gaseous state. The dash is the change of gaseous state directly to the solid state without going through the liquid state. This is sublimation. Sublimation is the change of gaseous state directly into a solid state and without converting into liquid state. So these are the answers that I already told you about. Now match the following. Column A consisting of some physical quantity and column B consisting of the units: pressure, temperature, density, mass and volume. Cubic meter, kilogram, Pascal, Kelvin and kilogram per cubic meter. Pressure. Pressure is force per unit area and this is Pascal. As I told you, it is Pascal. And temperature measured in Kelvin scale. Temperature, Kelvin scale. Density is mass by volume. Density is mass by volume. This is kilogram per cubic meter. Okay, mass per volume is density. Mass is in kilogram and volume is measured in cubic meter. Okay, keep solving the questions of the NCERT textbooks and let us go through the questions of question and answer for this chapter in the next part of it. Thank you.